Hello, everyone. My name is Donji, and this is Avi, and today we are hosting the Metabob Podcast. And today we're very lucky to have Yuval Alaluf. He is an amazing AI data science. What?
He's an amazing AI researcher.
An amazing AI researcher, and he has some of the coolest AI tech on how to make Toonifications. And he was covered on 2-minute papers, which, if you guys are not aware, is one of the most, I guess you could say, prestigious like AI publications. And it's one of my favorite shows too. So it's really an honor to have him on our show. And yeah, great to have you today.
Thanks for having me.
So first things first, we are going to jump into a clip of 2-minute papers, which kind of shows off his technology, and let's check it out.
Let's look at 3 amazing features that it offers and then discuss how and why it is better than its predecessors. Hold on to your papers for the first example, which is my favorite, image toonification. Would you like to see what the AI thinks you would look like if you were a Disney character? Well, here you go. And these are not some rudimentary first paper in the works kind of results. These are proper toonifications. You could ask for money for some of these, and they are done completely automatically by a learning algorithm. Whoa! At the end of the video, you will also witness as I myself get toonified. And what is even cooler is that we can not only produce these still images, but even compute intermediate images between 2 input photos and get meaningful results. I'll stop the process here and there to show you how good these are. I am blown away.
That's amazing.
2, it can also perform the usual suspects. For instance, it can make us older or younger, or put a smile on our face too. However, 3, it works not only on human faces, but cars, animals, and buildings too. So the results are all great, but how does all this wizardry happen? Well, we take an image, embed it into a latent space, and in this space, we can easily apply modifications. Okay, but what is this latent space thing?
So yeah, that's amazing technology you have right there. Can you explain to us, well, first, what's your background and how did you get into the AI space?
Yeah, so actually, I first got into machine learning in my the second year of my bachelor's degree, I think about 4 years ago, 5 years ago, in an introduction to a machine learning course. And during the course, I went to talk to my professor about getting into the real more practical things, deep learning, neural networks, and all that. And the first project I did actually comes from my biology background. So the first project I did was, a very classic classification problem between benign and malignant tumors, right? So that kind of was my first exposure to deep learning and computer vision. And the thing, throughout the entire project, the thing that really fascinated me was the idea of data. Right, the driving force of all ML, all AI is data. Right, you can build these elaborate models, but at the end of the day, if you don't have a good data set, if you don't have something that represents the true nature, then these models are quite meaningless. Right, so I was really fascinated with the data and specifically, the world of image generation. Generating new images. So that's how I really got started into the world of GANs. Right. And then through this process, I finished my bachelor's, started my master's in Tel Aviv University. And when I was looking for a topic to do my thesis, it was natural to go into this world of image manipulation, image generation with GANs. So that's really how I got started.
That's awesome. What was it, just more of a general background, what was it like growing up in Tel Aviv and in the tech scene there? I hear it's pretty cool out there.
So actually, I grew up in the States. I lived there for most of my life. I actually moved back to Israel at the age of 18. So most of
nice.
in the US, and then moved back here about 5 years ago, 6 years ago. Yeah.
Oh, that's awesome. What brought you out there?
Family, like my dad's work, and then when I was 18, we moved back here to Israel.
And then when you started doing your research, how did you make that transition from looking at benign tumors and then moving on to this awesome toonification?
Yeah, so I think there are two very different domains when we talk about computer vision and image generation. And after I finished my bachelor's, I went to study my master's at Tel Aviv. And when I was looking for a thesis, for a topic of my thesis, this idea of data really stuck with me. And then I decided to focus on GANs, the world of GANs and generative adversarial networks. And that kind of led me to work in the domain of StyleGAN. And this actually, the transition into the world of image generation was kind of natural to me. A good friend of mine started working on an idea about 1.5 years ago, and invited me to join to help him work on the project. And the idea of the project was kind of this similar to what we saw in the video about this the toonification, and talked about how we can use StyleGAN for editing images, right? So I'll share my screen and I'll show you what I mean by how we can use StyleGAN, to kind of edit these images. So StyleGAN, it's kind of considered the state-of-the-art GAN for image generation, right? But it's much more powerful than that. People actually saw that we can take StyleGAN, right? StyleGAN, how does it work? It starts off with some random noise, a noise vector, and from this noise vector, it generates an image. But we saw that they saw these works. They showed that we can take this noise vector and move along various directions in StyleGAN's latent space. Right, there's some direction, say that controls age. Okay, I can take my latent code and add this direction that controls age in order to get a new image of the same individual at a different age. Right, so not only does StyleGAN provide us with high quality images, but also it provides us with the ability to edit these images. And with the work that we worked on is actually called Pixel to Style to Pixel, PSP. And the idea here is that we want to perform the images, these edits on real images, right? So how do we take this image of, say, Barack Obama and find its latent code, this latent representation that will allow us to perform this editing that we saw, right? So the idea that we did was we want to build a network that takes this image and finds its code. And that way we can perform these edits. So that was the idea of the first work that got me into this field of image generation.
All right. So you would say that your current paper is kind of just an evolution of that existing technique?
Yeah. So the ReStyle was actually built on PSP. We saw that PSP was actually was outperformed the current works in the field. But there were still some gaps. I still saw that there was room for improvement, and that's what led me to ReStyle. And with ReStyle, we actually took a kind of a different technique with how we encode these images into StyleGAN. Up until ReStyle, there was 2 different techniques, and the techniques were either too slow and very accurate, or very fast and not accurate enough. And ReStyle was kind of gave us this middle ground between these 2 approaches. And with ReStyle, we showed that we can do this inversion into StyleGAN, but also allowed us to do this Toonify that we just saw using a nice little trick where you can perform a couple passes through the network in order to perform the translation.
All right. So did you try like other techniques before like settling on doing ReStyle as an iterative approach to generating the embeddings, or did you how did you formulate the concept?
Yeah, so the techniques that we tried, I would say more or less fall under the same kind of techniques. They're all these techniques that you want to build a neural network that takes the image and finds the latent code, the latent representation of the image. But up until that point, these techniques worked using a single pass, single forward pass through the network. So they were very fast, but it was actually a very, very challenging problem to ask a network to take an image and encode it into a small vector, right, and be able to capture all the fine details in the image. With ReStyle, we actually came to the conclusion that it's actually a very difficult task. If we allow the network to correct itself in an iterative manner, then we would be able to get a much more accurate latent representation of the image. Right. So the different technique that I would say with ReStyle was this idea of iterative refinement, where we gradually improve the encoding of the image. Right.
And how do you ensure that keep moving in the same direction as you're doing each pass of the iteration?
Yeah, so that's a good question. So each step, when you pass the image through the network, you compute a loss between the the output image and the target image, and by computing this loss, it guides the network into which step how to correct itself in the next step of the forward pass.
Did you have to take into account anything else while you were going through each pass? Or is there some other component you need to add in or keep track of as you're iterating?
So actually, I was actually pretty surprised that there wasn't too many components of or formalizing ReStyle. It was pretty much taking the existing techniques and adding this refinement, this iterations. And actually, it was very surprising that it actually pretty much worked without too many games, too many tricks. So the way we came to this, how we figured out that it worked quite well is when we tried to build on the idea of ReStyle. We started small, right? We want to see, first of all, we want to break PSP and these previous approaches. We want to see, where do they work well and where do they fail? So we started throwing very, very difficult examples through the existing methods to see, where do they work, where do they not work? And by seeing where these previous methods fail, we were able to understand, how to build ReStyle in a way to try to overcome these gaps.
So this was just a trial and error process on your end? You just found a bunch of weird looking faces and said, yeah, we'll try and encode these and will these work? Or what was your actual approach for that?
Yeah, so I think a lot of research is trial and error. And there was a lot of brainstorming on how do we break the existing methods into smaller components to understand each of the components and how each of them works and what are the limitations of each of these components. And by doing that, we're able to see how do we make these necessary adjustments in order to improve the final result. And I think with with any research that you do, it's kind of funny. A good friend of mine told me this. He said he summed it up very well. He said that with research, you never know if the idea doesn't work or if you have a bug in your code, right? So luckily for us, I don't think we have a bug in our code, and the idea ended up working well. But it's always a challenge when you're doing research, right? So I always start small and slightly build from there in order to get to the final result.
So when you say you started small, did you start with doing the sytlegan with the face generation, or did you use some other sytlegan or just another generative network to do that? Or did you just look at the embeddings themselves in the output?
Yeah, so I started, I focused mainly on sytlegan. That's the model that I typically work with. It's really considered the state of the art today in generation. And we did start on working on faces, and then we extended from there to other domains. I think the reason why a lot of these works on GANs, they focus on faces, is because we as individuals were very sensitive to the changes when we look at images of other people. We can notice these small changes. Say if you're able to reconstruct the individual's eye color or the hair. So we're very sensitive to these small changes. And then it allows us to easily identify limitations of existing works and how we can overcome them.
Yeah, so you'd say the qualitative evaluation capability of each person is much greater with the face than something like a car or a horse or something, right?
Yeah, exactly. So like definitely, so that's really why we started with faces, and the idea of, like, what you brought up about qualitative analysis of the results. I think when you're comparing, when you're trying to understand if your model works, doesn't work, you have this ability to, try to compare quantitative results, compare methods quantitatively. It could be various metrics on the results. We also have this idea of like qualitative comparisons, visualizing taking the images of each of the outputs of each of the models and visualizing, seeing what are the differences between the resulting images. And I think qualitative results are much stronger than quantitative analysis here. So that's really what our focus was.
But so with all of these generative like AI techniques that always produce some output, it's always kind of difficult to get a good understanding about how you're improving your model and how things are going without having some sort of like clearer metric other than just loss and accuracy. So what was your sort of approach to know that you were continuing going on the right track and that like overall that you were getting a good production of these latent space embeddings without necessarily having to go through every image hand by hand that it will generate, right?
Yeah. So with GANs, quantitative comparisons of different methods is quite challenging. From the best of my understanding, there's no one method, there's no one metric that really is able to say, this method is able to better generate images than this other method. Right? You can compare how we're able to, how do we typically check if we have a good latent image? Take latent embedding and we pass it through sytlegan to get the output image, the reconstruction of the input image. And then we compare the similarity between the input image and the output image that we got with sytlegan. So there are quantitative things that you can do. You can compute losses between the output and input images. But I feel like this isn't enough, right? It's always, you can always try to lie with numbers, right? And the best way, in my opinion, to compare these results when you're talking about GANs and image generation, image manipulation, is really visual results. Just looking at the images and seeing, which, like, to be honest, which one looks better. In my opinion, that's the strongest way to compare methods.
Yeah, it's especially when you're generating images, I guess the intended consumer of these images is people. So as long as people find them to be high enough quality, then you've produced a good output, right?
Exactly.
So moving on to a slightly different topic, how was the actual like model training process overall? Did you have to go through a lot of iterations on how your model is structured or anything like that?
So there was a lot of there was a lot of works with building the correct model, building the correct architecture, finding the correct loss functions. But with everything that I do, with all the research that I do, regardless of the component that I'm trying to optimize, finding the best architecture, finding the correct loss functions, I always start with a POC, a small, I take a small set of images, and I make sure that my model is able to perform and do what I want on this small set of images. Because then I know that there's potential for this model to work well, right? And then I start adding more data. I start changing the model architecture, relaxing the assumptions that I've made on my data, and things like that. And every time I do this, I always change one component at a time in order to better understand, how does each component affect the overall system? How changing the loss functions or is each of the loss functions really important, right? How much do they affect the final result? And that way I'm able to really understand, what do I have to focus on and what's a bit less important. And this really allowed us to, kind of from the bottom up, take each of these small components and combine them together in a way that really gave us the final results. I think throughout this, this building process, one of the things that really helped us into getting the final result was visualizations. visualizing the training process, the losses, visualizing intermediate results throughout the training process, because this really helped us understand where our model was going, very early on in the when we designed the system, right? So we were able to do some very quick iterations in order to get the final results.
Did you utilize any like particular techniques, or did you just do this all sequentially as you were exploring the process and getting a feel of the domain?
Yeah, so it was mainly trial and error. It was mainly like sequential. Let's focus on the architecture. Okay, it seems like we got a good architecture. Let's focus on the losses. For example, with the PSP, my first work, one of the things that really made a huge difference was that when we're talking about the human domain, for example, we're very, like I said earlier, we're very sensitive to changes in eye color, in head shape, and things like that. So we actually added a identity loss, right? A loss that really focused the model on preserving the individual identity, right? So we built on existing losses and said, let's introduce a new loss that, from what I understood, was the first time that this loss was used in GANs. And we saw this was a huge improvement over previous works. So just understanding limitations of existing approaches and the tools that people use, and seeing how we can overcome these with new techniques really made a huge difference in our final results.
Nice. Did you ever have to like go back and like retool how you were going about it? How many like dead ends did you run into while doing the research?
Endless amount of you take one step forward, two steps back. It's a lot of iterations. And it can be kind of tiring, but at the end of the day, if you make a good enough plan and you have a good enough setup for running experiments and comparing the results, it really helps make progress in the research.
And I get one question about the way you transform the initial image to the second one. When you add you stylized it in the output. So did it take any sort of like artistry to like make some sort of, I don't know, mask or overlay or something to, how did you design the Toonification process?
Yeah, so actually there was no special things that we had to do for the Toonification to work well. We actually, if we talked about earlier, like sytlegan generates images of, say, human faces, of cars, animals, like we saw in the video. We actually changed the sytlegan to a sytlegan that knows how to generate toons, animated images. And then we just used the same encoder that we had for faces, paired it with the sytlegan for toons, and then we were able to translate between the real images and the toons. Right? So it was very surprising that it worked, and it worked quite well without too many tricks. Right? So that was actually kind of surprising that it actually worked quite easily.
You mentioned in your paper that you had to do some bootstrapping, though, for getting better quality outputs from the sytlegan. Can you explain a little bit about what that process is and how it affected the whole thing?
Yeah. So when we talk about Toonification, right, we can think about it as two different tasks. We can think about it as we want to take an image and find its latent representation. That's one task. And the other task is take this latent representation and find it and change to the Toonify style, right? And both of these tasks by themselves are quite challenging. So we typically ask a network to do this transformation, these two steps together. And asking the network to do these two things together is quite challenging. So with the Bootstrap, what we did, we said, let's split this task into two parts. Let's first make sure we get a good latent embedding of the real image. And then we'll use another network to take this latent embedding and change it to its Toonify version. Right, so the Bootstrap was, say, let's take a challenging problem, break it into two, and then it simply works much better because we make sure that each network can focus on one thing rather than focusing on two different things at once.
So you would, correct me if I'm wrong, but you would sort of describe the Bootstrap process as like a translation between one set of embeddings to the embeddings required for a different sytlegan, right?
Exactly. Yeah.
So this is maybe a weird question, but would this work with any sytlegan? Could you make a face out of could you make a car out of somebody's face if you did the embedding properly?
So if you could do that, that would be pretty cool. But I think why the Toonify worked very well is because the two domains of human faces, like real faces, and Toonify faces are very, very similar to each other. So it allowed us to do this transformation quite easily. But if I take two very different domains, I don't think it would work, right? So we actually leverage this like domain knowledge of doing this transformation between two similar domains in order to perform this translation.
That's actually pretty interesting, because I did notice that in the Tunit Papers intro, when they were playing the clips of the Toonify one, it worked really well. But when we were trying to Toonify the animals, it didn't work as well. So I guess, like, for example, if you were doing horses and then you went off of like BoJack Horseman, the cartoon, you could, like, if you had a whole bunch of cartoon horses, it'd be easier to make accurate animal translations.
Yeah. So yeah, you really have to understand what, like, the two domains that you're working with. How, first of all, you need to know that your sytlegan is good and is able to generate very, very good images of the domain, and the two domains have to be similar, right? But there's a long way. There's still a lot of work to be done with sytlegan in order to, for example, natural images, and really making a all-purpose generator that's able to generate multiple domains using a single model, right? So there's still a lot of work to be done in this domain.
Yeah, the holy grail of the general purpose image generation system. It's definitely something that's, I'm looking forward to it. Might be very interesting. How do you actually, about the future of the space, what do you think the next big innovation would be?
Yeah, so the future of image generation moving forward, I would say, so far with GANs, we focus on images, editing images and things like that. Hopefully in the next year or two, we'll see more of moving into the domain of videos, encoding videos, editing videos, things like that. I think we're starting to see GANs being used, for example, in the film industry, in VFX, CGI, things like that. It's still a very, very long way in my opinion, for being something very practical and useful in the day-to-day. But I think we're starting to move in that direction. So I think hopefully we'll see GANs being used more in the film industry, for example, augmented reality, and things like that. But as you said, sytlegan that is able to work, or GANs in general, they're able to work on a lot of domains, on all natural images, for example, full body generation. That's something that would be very, very exciting to see. For example, full body generation, let's say in the video game industry and things like that.
I got one question about the speed at which this algorithm works. How fast is it? Is it real time? Could it be used in real time applications?
So it's near real time. Each image is less than half a second, so it's not quite real time. But there has been, a couple of years ago, it would take you several minutes to take the image and find its latent representation. So I think we've come a long way, but I think there's still a lot of work to be done. Yeah.
And then I see on YouTube and TikTok, on TikTok and Instagram, there's always this Toon thing challenge where they hear people like look at themselves on the phone, and then there's that song from Up, like da 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 da, and then they get to look at each other at themselves as like tunes, and everyone's like, wow, what do you think about that and the commercialization of these Toonification projects?
So I think from the best, I would say I'm more familiar with Snapchat and the filters that they have, and I think it's quite amazing the things that these companies are able to do with their applications and these filters. Because if we think about it, all of my works have really focused on images, and they do take half a second to run. They're not real time, but these companies are able to do this not only on in real time and on mobile, which is also a very, very challenging thing to do, But they're also able to do this on video, and it's quite amazing that they're able to do this. It works very, very well. And I don't know exactly all the secrets that they do that Snapchat uses for these filters, but it's great. It's pretty incredible, I have to say.
I guess for them, it's like they have just one core engine where they just have to be able to map some sort of effect to a face and just know where the eyes and lips are. And then they just kind of, they have like a core engine that runs really fast and they let people build on top of it, I'm guessing. How do you think that they build, like, how would you guess that they built the Toonification process? We don't expect you to have the perfect answer, obviously, because we don't know Snapchat secrets, but how would you guess that they built that?
Yeah. So typically, from the best of my understanding, how do we take the transition from working on images to working on video? Is we mainly take the video and break it up into frames, and we work on each frame individually. But then you have this issue of, this idea of temporal smoothing. You have to have a smooth transition between each of the frames. Because if we're working on images and we work on each frame independently, nothing that connects each of the frames together, right? So what I have to say is they work, I would guess, they work on the individual frames.
Oh, wait.
And somehow they're able to...
Wait, give me 1 second.
We're having some connection issues.
Give me 1 second. It might cut out real quick. Should I do it?
No problem.
No?
Just leave it for a second. It should resolve itself. It was fairly good connection-wise.
Floor 2.
It was fairly good connection-wise.
Okay. Let's just restart that one segment. So maybe I'll do it.
It may end the meeting.
No? Yeah?
You can try it.
Because it's pretty choppy now.
All right. Sorry about that. Yeah, I think we can just re-ask the last question again and go from there.
Okay. So if you had to guess, how did they build the Snapchat filter with the Toonification process using the real-time video?
Yeah, so that's a good question. I think if I had to build a filter myself, what I would possibly do is, work on each frame independently. Right? I think most works today, that's what they do. They take a video and break it up into individual frames, and they perform this, the filter, this transformation on each frame individually. But then we have this issue of, you have these sets of frames, each of them you transformed into the Toonify version, for example, but now you have to kind of stitch everything together. And if we work on each frame independently, there's nothing that really connects each of the frames together. So I assume that there's some sort of mechanism that they use in order to stitch all these frames, so we get this smooth result that we see in the end.
Do you think algorithm like ReStyle would be able to be used to handle the temporal image smoothing as well, or would you think a different approach would be necessary?
I think ReStyle has the potential to be used for this temporal smoothing, but it's not enough. Right, so with ReStyle, because we're able to work in a couple of steps, we encode the image, we can actually, for example, if we working on a particular frame, we can start off the inversion process and initialize it with the result of the previous frame, right? And because we're using the previous frame, we have information from the past, and we're able to get possibly a smoother result. But I still think that you have to have some more an additional constraint or additional mechanism that its main purpose is this temporal smoothing, right? But actually, I've never tried this out, so it would be something very interesting to try. Extending ReStyle to work on videos.
I mean, you did mention how it just happened to work very well without a whole lot of fiddling with after you've tuned it, obviously. But it may potentially be may potentially have very good results by doing this. Yeah,
and actually, one of the things I'm looking forward to in the future of my research is moving on to and getting into the field of video generation, video editing. So I think that would actually be a quite a nice, easy, easing into the domain. So I may try it out in the future.
So is that going to be one of your like upcoming papers then, more in the video domain, or are you going to be doing some more refinement on image editing techniques in the short term?
Yeah, so right now I'm still working on like playing around with images and manipulations, trying to build on my previous works. But I hope video would, in the next year or so, I hope get into that domain a bit more. I think there's the jump from working on images to working on videos. There's a lot to learn, right? So there's definitely a learning process where I have to figure out what methods exist and do this the exact same process that got me into the field of image generation, but now on videos. So it's a lot of work, but I'm very exciting and very excited to do this.
And when you got your paper published, I just want to change subject real quick. When you got published in 2-minute papers, what was that like? Were you like super stoked?
Yeah, I was actually very surprised. He sent me an email and said he wanted to feature my work on his channel. It was very, very surprising. Actually, I was a big fan of 2-minute papers before he reached out to me. So getting an email from him was pretty amazing. That he really enjoyed my work. And what I really like about 2-minute papers is really that he's able to explain papers very, very simply, right? Even if you're not from the domain, he's able to focus on the key parts of the paper, and really gives you a nice introduction to different domains in the field. And I think it really makes the world of academia very a lot more accessible to the general public. And so things like 2-minute papers, really awesome to see, and really awesome to see a lot of people doing similar things.
Yeah, what he's doing for the AI space is huge. I mean, there's so many research things that I would have never found out if it wasn't for that show. Also, he just makes you sound like a total boss because he goes, oh, wow. He's so enthusiastic when he talks about, your paper and what it holds for the future. So speaking of what it holds for the future, have you thought about commercializing your work?
So I've thought about it, but my goal in doing these works is a bit less commercial, or getting working and releasing these papers and seeing what people go out and do with them. For example, with PSP, when we published, I think a bit over a year ago, we were very surprised with the feedback that we got from people. We published the paper and we published our code, and we started to see a lot of people take it and post a bunch of different things on Twitter, a bunch of different applications using PSP. And that's really made the entire process of getting into this field so much more enjoyable, because you really see that people are using the work, it's having an impact, and they really enjoy it. They're sending feedback, and it makes the process a lot more fun. And that really pushed me to continue the work.
Oh, so you kind of enjoy the open source aspect of the community, where you're looking to see what people build with what you've created.
Yeah, exactly. I mean, my work was built on previous work. So having my works and seeing other people run with it is that much more exciting, right? So and it's always nice to see the ideas that people come up with. They say, they add this small change here, they add this component here, and it changes a bunch of things. And it's really awesome to see, wow, I can't believe they thought about this idea. So that's really the fun part and the enjoyable part of this process.
And so if you had to imagine yourself of where you'd be in 5 years, I know the typical boring interview question, where would you be?
Good question. I ask myself that a lot. I do look forward to moving from the academic world into more of production, working in startups in a company, because I think when we talk about these works that we see in the academic papers, even my works that I published, we see that it works in particular cases, but there are cases that it fails. And I think that when we move from the academic world to the real world and talk about production, there are many challenges, new challenges that arise. So being able to understand the limitations of these works and being able to overcome them in production is very, very, I think it's something that very intriguing, and I think opens up a bunch of new challenges to look forward to.
Yeah, that is interesting, because there's always this balance in the world of actually doing production work where sometimes the answer is not the most the bleeding edge technology or like the sexiest answers. Sometimes it's some like weird hack that's like people are like, oh, you did it that way, and then it's just like you kind of have to separate yourself from the love of the technology, and then you have to figure out more of like what's the simplest solution, or it's a different process, I believe, from research, right?
Exactly. If it works, it works, right? So it's when you're writing a paper, you're trying to find the best results to showcase in your paper. With production, we're trying to find the worst results. Where does our model fail? Because if you're in the real world, there's like consequences to if your model fails, right? So you have to be able to quickly identify the limitations of your model and understand how do we overcome these limitations. So I think there's a big gap between publishing papers and working in production. So as you said, yeah, a bunch of different challenges, and yeah.
And we saw this. I'm just kind of curious, like if you were to do video work, would you want to be doing the same similar thing, or working on faces, or would you be interested in working on different things as well?
Yeah. So I don't have anything particular in mind, but I do think that I would start with faces. Like I said earlier, I think when we work on faces, we're much more sensitive to these changes. So it helps to really get into the field, and it's actually a well-defined domain, right? Because when we look at images of faces, well, they're more or less the same, right? Different. It's everything is located pretty much in the same place. Different skin colors, different hair, different styles, things like that. But they're more or less well structured. And then if you're able to solve the problem on the faces, on the face images, and then you move on to more challenging domains, I think that's the correct way to go about it.
Okay, so you're trying to master faces and then maybe move into like face video and stuff like that.
Exactly. Yeah.
One thing that I kind of want to do, just a little fun, is have you seen this newest 2-minute papers one?
I haven't seen the video, but I'm a bit familiar with the work. Yeah.
Yeah, I thought this was pretty cool. Speaking of video work, where they're doing the basically Photoshop effect of masking, and they can remove backgrounds in real time. I really appreciated that one. Did you have any other favorite 2-minute paper works?
Wow. To be honest, I haven't had a chance to. Last time I saw a video was a couple months ago. I have a lot of videos to catch up on. I think one of the very interesting ones was on NERFs. It's a field that I've actually started to try to get into, try to understand more how NERFs work. And he explains it very, very nicely, how NERFs work. And I think his was one of the first videos that I saw when I tried to get into the field and try to understand what's going on there.
What is a NERF? Not a Nerf gun, I'm assuming.
So yeah, so NERFs are neural radiance fields. Now I'm not an expert, so apologize if I say something correctly, but pretty much with NERFs, we're trying to build a 3D representation of a scene, right? So we have like a bunch of images of a scene, and we want to try to to train a neural network to encode this 3D scene in a way, right? So NERFs, I think if we're talking about the growth of GANs in the past year or two, I've actually noticed the amount of papers that are published. I think NERFs are growing 2 times faster than GANs in the past year. So it's also a topic that's become really, really, really has a high focus in the past year. Yeah.
Mm-hmm. Yeah, I'm just kind of going on a limb here, but so you're saying that you could just take different images, like I could take like 3 different images of something and it can reconstruct a 3D model?
Yeah. So you take, let's say, I don't know, I really don't know how many images you need, but say 50 images of the scene from different viewpoints and different, places. And then you're able to generate a complete representation of the scene. So you're able to generate, what's called novel views of the scene. So, show how the scene would look from a completely new point.
Mm-hmm. Well, what's actually very interesting is comparing the way that humans learn to machines. And it's kind of like, if you look at a macro point of view, it's almost like we're training a single big organism how to do very specific things. Like I remember when I was studying how to draw, they would actually ask us to imagine to draw the other side of an object, just kind of like how you're describing, as an exercise to learn perspective better. So I think the way that humans learn, it's kind of similar, actually. Like I actually had to do that.
Yeah. So I think the thing that's very, very common to both, how humans learn and how machines learn is the data, right? We need to train these models, need a lot of data, and we as individuals, our data is our, life experience. That's how we learn, right? So that's how I like to think about it.
Yeah. And was there anything else that you wanted to cover?
No, I think you guys covered. We talked about most of the things. Yeah.
Don't have any showcases or anything else you want to plug last minute?
I'll say that one of the things that I've really enjoyed about this entire process is the working with other people in the field. I think that a lot of people, when they start off in a new field, they don't really know where to start. And I've had actually the honor of working with some really awesome people that have helped guide me through all my research, and they're a big reason that I am where I am today. So for anyone that's trying to get into the field, I say one of the most important things is finding a topic that you really enjoy, but also finding people that you want to work with. So people that you can ask questions and things like that. So it's really important to find what you're passionate about, but also find the people that you can collaborate with and to help move forward.
And yeah, that actually brings up another point. For junior developers, do you have any specific advice for how to get into your space specifically? Like what tools should they be using? What should they be setting up on, and what connections should they be making?
Yeah. So I think what's nice about today is that this field has become a bit more accessible than previously. I think the first website that I go to when I try to start a new research direction is Papers with Code, and there you have all the published papers that come out and all the code that's released, and also allows you to compare different state-of-the-art methods. And this way I'm able to, you're able to really get these, look at what's available today, the existing methods, go to the code, start playing around with their code, and then build on from there. For anyone starting to get into a research, I think, find the existing works and start to break them, right? What I talked about earlier, try to find these stress tests and see where these models, fail. And that way it could probably give you an idea of, how do I build on these existing models? What are the limitations of things that exist today? Do they take too long to run? Is the model very large? Does it fail on specific subcases? And that way, I think that's a good entry point to, building on the existing works and finding a new, research direction.
And for people who are a little further along in their process and want to get their work discovered, what did you think that you did right to get your paper featured and get so much attention?
I think a lot of it's social media. What's nice is when I publish my works, I post on Twitter, and hopefully get some traction. And with Twitter, I've been lucky that it has gotten some traction, and it has reached a somewhat wider audience. But post on social media, whether it's Twitter, let's say Reddit, and then hopefully that way you'll be able to get to a wider audience, and then from there branch out.
How often do you post?
Not too often. Usually when I have a new paper that I want to publish, or I'm playing around with an existing model and I have some new results I want to try, things like that. Not too often, but there are. Yeah, but there are, I think, for anyone that's trying to keep up with, the papers that come out every day, there are definitely people on Twitter that post, the top papers that they see on archive every day. For example, AK, very, very popular on Twitter, and that helps to really stay up to date with literature. So, follow the correct people on Twitter, and hopefully that helps you get into the field. Yeah.
Awesome. Well, it was really awesome to have you on our show today. And yeah, quite an honor because your work is really cool. And yeah, I hope to be having another interview with you once you come up with your next coolest thing.
Yeah, thank you guys for having us. I had a really awesome time.
Yeah, us too. Looking forward to seeing all of your future works.